Math 7 students. It is Monday and we're going to start our new lesson. We're not going to do 11.2 because there just isn't time enough to do everything, but I've picked the most important lessons to get you ready for pre-algebra next year. So today we're going to do 11.3 and let's say a prayer. It's going to be a lot of fun. Father in heaven, we just thank you for this day. I pray for my students right now that you would help them to focus and learn the very best they can, and you'd strengthen me and help me to be the best teacher I can, using words that will best explain this concept. In Jesus' name, amen. Okay, now, if you got the email, which if you're watching this you did, there was an attachment, and on it there was a worksheet, and it had a bunch of shapes on it, and they were not colored in. And I asked you in the email to please color them in. So I hope that you did that, like this, and I hope that you cut them all out, all right, because we all need them in pieces. So we're going to talk about what the Pythagorean theorem is and why it works, okay? Actually, the first thing I'm going to do, I'm going to change gears for just a second here, is I want to write down the Pythagorean theorem, which is this, okay. Okay, can you see that okay? The Pythagorean theorem says that if you have a right triangle, one leg squared, which would be a squared, plus the other leg, b squared, is equal to the hypotenuse squared. Now it's very important. C is over here by itself. C is always the hypotenuse. How do you know which side is the hypotenuse? It's the longest one and it's across from the right angle. It's really important that you get that. C is the hypotenuse and that's the length that's by itself. Now this is a very important, famous formula, thousands of years old. A man named Pythagoras discovered it, and we're going to see why it works using our shapes, okay? So I'm going to use the ones that I have here with construction paper, and we're going to talk about it for just a minute, all right? So here I have my triangle, and just like in the picture I showed you, one length is A, one length is B, and the hypotenuse is C. And C is the hypotenuse because it's across from the right angle. Okay, now, A is a length. If I wanted to square that, it could actually be an actual square. So that this length is the same here as A, and I multiply it by itself, A, and if I was going to find the area, it actually makes a square, which would be represented by a squared, a times itself, okay? The same works for B. So if I had this B length here, and I squared it, I would have a second length there, and if I multiplied those, I would actually get a physical square, B squared. That's where why we call the number 2 here square, because whatever times itself makes a square. All right, and then if I had C here, that would be this length, and again, multiplied it by itself, so I created a square. I would have this square here. So, literally, A squared, the pink one, plus B squared, the yellow one, should all add together and be the same size as C squared, the big one. And we're going to try to figure that out using a puzzle, using our pieces. Now, on this yellow square, you can see there's 2 lines that go across it. They don't go from corner to corner. This is on purpose. This is the shape it's supposed to be. What I want you to do is get your scissors and cut these lines. So you'll end up with 4 pieces. Okay? And I have some right here. So I want you to pause the video and go ahead and cut those up, and we'll come back in just a moment. So I will pause what I'm saying, and you can go ahead and do that. Okay, so coming back, what I want to show, now these are the same as this, right? It's just cut up into 4 pieces. So what I want you to do is to take your pink square and put it on top of the purple one and see if you can figure out how to get all of them to fit on top. They should all work out. So again, I would like you to pause the video and try to figure out the puzzle on your own and see if we can make it work. So go ahead and do that. Okay, so you want to know the answer? I will show you. It's a little tricky. Here's the key. Your corners. Corners of the yellow. If you put them all in the corners, now I hope I'm doing this right, like this. See how I have my 4 corners? Then there is a perfect space for the pink one. Isn't that fun? Now I challenge you to go and let your family try it. Your younger brothers and sisters, I bet you could even trick some older ones or your parents to see why a squared plus b squared actually does equal c squared. All right, well, we're going to go on with our lesson for now. So I want you to take out a piece of paper, and we're going to go to the overhead, and we're going to practice using this. I hope you enjoyed seeing in a very real, visual way that the Pythagorean theorem is true. Are we all ready there? Are we focused well? All right, so I'm going to keep going. Thank you. That was my husband, my cameraman. So as we said before, a squared plus b squared equals c squared. So that means this length multiplied by itself times this length multiplied by itself is equal to this one squared. And it only works for a right triangle. It works for a right triangle only. Okay, so you need that symbol right there. You have to make sure that you have that. Okay, so let's do some problems. I already wrote this down, so you can go ahead and pause the video so that you can write it down. But I'm going to keep going so that we have a shorter video. The size of a television screen is equal to the length of its diagonal. Did you know that? When you're buying a TV, what they describe it as. So if they say a 29-inch TV or a 60-inch TV or something really big like an 81-inch TV, that is the diagonal across the screen from one corner opposite to the other corner. So that's like this. Okay? If the width is 15 and the length is 20, what is the diagonal length of this particular TV? Now we know if we have a rectangle, then I'm going to have 4 right corners. So I am going to have a right triangle here. So I have 15 squared plus 20 squared equals, and I'm going to call this c squared. Now remember, I know that c is the diagonal is the hypotenuse. It's c because it's across from the right angle. Very important. All right, so I'm going to work this out. 15 times itself is 225. 20 times itself is 400. Okay, so remember with PEMDAS, exponents I do before adding. So that's why I'm doing this first. And I get 625. And I take the square root, and I end up with 25. Now, we talked about this in our last lesson. When we take the square root in an equation, you're going to get a positive answer and a negative answer. But with the Pythagorean theorem, you're actually talking about a real length on a shape. So you can't have a negative length. That doesn't exist. You have actual real inches. So it has to only be the positive answer. Okay? Unlike temperature. Like temperature, for instance, you can have a negative answer that's a real thing. Okay? That's measured by going below 0. not for length. So that's how we get that. All right, let's do this one, another one. So here's my right angle. C is across from it, and that's already labeled. So I have 8 squared plus a squared equals c squared. And 8 times itself is 64. I do that twice. And I get 64 there, so I'm going to add those together. Sorry, I'm going kind of fast. Feel free to pause anytime. I will take the square root, and this is one you can look up on your calculator. So the calculator for this is allowed on this one, okay? So you get approximately 11.3. If you look on your calculator, there is a little button that should have that symbol on it. So you put your number in, and then you push the button, and the square root pops out, okay? All right, number 3. Now this time, we want to find b, and we know c. C is across from the hypotenuse. This is why it's so important to know what the hypotenuse is. So I'm going to have a squared plus b squared equals c squared. That's my formula. Here's one length. That's 11. A squared is 11 squared. B squared, I don't know. And then I have c this time. So it's just a little bit different, okay? 11 times 11 is 121. 20 times 20 is 400. Subtract 121, and I get b squared equals, let's see, that should be, I think, 279. I'm just going to check it to be sure. 400 minus 121. Yep, 279. Now I'm going to take the square root, because remember, square root undoes the power of 2. It's the opposite function. And I get 16.7. Okay, so the side of the triangle is 16.7. Okay, we're going to do one more. Your homework problems are like this. If A is 5 and C is 13 in a right triangle, find the perimeter. Okay, well, perimeter means the distance around a shape. Or around something. So I have a right triangle. I'm going to draw that. Now when they give us C, they mean that that is the hypotenuse. So I know that's going to be there. Okay? And they tell you that in the book. They say legs A and B, hypotenuse C. Okay? So if A is 5 and B I don't know. Okay, now I want to have the perimeter around. The only problem is I don't have B. I have 5, I have 13. For the perimeter, I'm going to want to add A plus B plus C, don't I? So I don't have B. Well, that's where the Pythagorean theorem comes in. I can find that missing length. So I'll have 5 squared plus b squared equals 13 squared. So 5 squared is 25. 13 squared is 169. I'm going to subtract 25. And I get b squared equals 144. Take the square root, and b is 12. Okay, now be careful. B is 12. Okay, well that helps me, but the question is find the perimeter. So I'm going to put A in, which is 5. Sorry, this is kind of messy and I'm running into something else. I'll put this down here. So the perimeter is going to be 5 plus 12 plus 13, right? And when I add those all up, I get C, 30. Okay? So my answer is 30. This is the first step, but the actual answer is 30. Okay, so I want you guys to go ahead and try these three, and we'll come back in just a moment. Okay, so let's figure this out. I've got 9 squared plus 12 squared equals C squared, across from the hypotenuse. 81 and 144 is 225. I take the square root and I get C equals 15. Okay, this time, C is my missing length here. Sorry about that. I have decimals. That's okay, they don't scare me. So I'm going to have 0.5 squared plus 1.2 squared equals C squared. Okay, 0.5 times 0.5 is 0.25. And 0.1 times 0.12 times 0.12 is 1.44. And that equals C squared. All right, now I'm going to add these together and I get 1.69 squared. Maybe that looks a little familiar if you know what the square root of 13 is, and you get 1.3. Okay? All right, the last one. Here I'm trying to find A, so I'm going to have A squared plus 9 squared equals 14.2 squared. And let's see what I have. A squared plus 81, 14.2 times 14.2, and that's 201.64. I'm going to subtract 81, and I get 120.64. All right, and I'm going to take the square root of that, and I get 10.98, which is approximately 11. Okay? Alrighty, so that's it. I hope you enjoyed our puzzle. This is your lesson. I will send that in the email, and I hope that you have a great Monday. Bye now.